For this problem, I want to solve this for n. So what I'm going to do here is I'm going to try to isolate that n by itself. So to solve this for n, I'm going to add 10 to both sides first. And so that's going to give me, that's going to cross out. Then this will be negative 5, parentheses, 2 minus 15 n. And that's to the 3/5 power. And then this is going to be negative 40 over here on the right-hand side. Now, here's the next thing. I cannot touch what's in the parentheses just yet, so I've got to get rid of this negative 5. But I'm not going to add 5 to both sides. This is multiplication, so I'm going to divide both sides by negative 5, and that's going to give me 2 minus 15n, so 2 minus 15n to the 3/5 equals 8. And my handwriting's a little bit sloppy right there. This is 2 minus 15n to the 3/5. Now, for this, now that I've got the parentheses by itself, I can get rid of this rational exponent by doing its reciprocal, so that would be 5/3. So I'm going to raise this to the 5/3, and then I'm going to cancel out. And so this is going to cancel out and leave me 2 minus 15n, and then I'm going to put 15n, let me put it, 2 minus 15n equals, and then if I plug this into the calculator, 8 to the 5/3, I would get 32 for that answer right there. And then continue to solve this for n, so I'd subtract 2 from both sides, and that would give me negative 15n is equal to 30. And then finally, divide both sides by negative 15. That gives me a negative 2 for my answer for the essential question. And so if you look at that, what you'll notice is some of the things that we've covered of this unit were these topics. It's solving equations with rational exponents, converting radicals to rational form, solving equations with radicals, and simplifying radicals. So that's all the new stuff that we've done thus far. Now what we're going to do is let's go back and review, because you've got spiral on there. And so there are a couple of questions that we're going to review. So take a second and write this one down. And the directions say to find all zeros, and it says 1 0 has been given. This was actually from test 4 prior to it. So go ahead and write it down. So I've got f of x is equal to x cubed minus 11x squared plus 13x plus 33 with a given 0 of 3. With a given 0 of I've got f of x is equal to x cubed minus 11x squared plus 13x plus 33 with a given root of 3. Now, just to do a quick review of some of the topics from test 4, what I have here is I have a polynomial that has a degree of 3. That's my highest exponent. And because that's a degree of 3, that means I know that I will have 3, not more, not less, but I will have 3 answers. Now, what I give you is, I tell you that one of those answers is already 3. So the question remains, what would be the other 2? So that's what you're asking to find here. So 3 is one of my answers. So the way we do this is we pick up with synthetic division. And so that's what we're going to do. We're going to do synthetic division. So we're going to put that answer, that 3, inside of my half box and draw a line. And then we're going to put our coefficients down from the polynomial. So this is understood 1, so that's a 1. That's negative 11, that's 13, and that's 33. So I'm going to put down my coefficients from my polynomial, 1, negative 11, 13, and 33. And we're just going to do synthetic division on it. So synthetic division, always bring down the first number, so that's a 1. Then multiply. 1 times 3 is 3. Negative 11 plus 3 is negative 8. And then negative 8 times 3 is negative 24. And then negative 24, 13 minus 24 is negative 11, and then negative 11 times 3 is negative 33, and 33 minus 33 is 0. And always remember, guys, this last number is my remainder. Now, it shouldn't be any surprise to me that my remainder is 0, because I already told you that 3 was an answer. So since my 3 is an answer, I know I'm going to get a remainder of 0. Now, what gets left behind is that I'm going to have to do my what I'm going to have remaining is a quadratic function. And so what I'm going to do is, this is my value for A, B, and that's my value for C. And so this is my quadratic function that gets left behind. And so my quadratic formula is negative B plus or minus B squared minus 4AC all over 2A. And so then I'm going to plug that in, and I'm going to have 8 plus or minus the square root of negative 8 squared minus 4 times 1 times negative 11 all over 2 times 1. And I don't know why the pen is acting up sometimes. But all right, so then that's what I'm going to have. So that's negative 8 squared minus 4 times 1 times negative 11. That's what's inside the parentheses right there. I'm going to write it again right here, negative 11. And so remember, you can't plug this whole thing into your calculator, but you can plug in this value, the discriminant, and if you plug in negative 8 squared minus 4 times 1 times negative 11, you should get 108. So that's what you're going to get inside the radical. So what I have here is 8 plus or minus the square root of 108 divided by 2, which that is a good answer, but I always have to be on the lookout to see if I can simplify my work. So I'm going to see if I can divide 108 by 4 to simplify it, and that's what I'm going to do right quick. So 108 divided by 4, actually it does work 27, and so I'm actually going to try 36. So 108 divided by 36. 36 actually works. So 36 times 3 is 108, and the reason why I want to use 36 is because the square root of 36 is 6. So I'd have 8 plus or minus 6 square root of 3 over 2, and that's a good answer, but for the final thing, I notice I can divide everything by 2. That's right, I can divide everything by 2, and so that's going to give me 4 plus or minus 3 radical 3 over 1. So my two answers would be 4 plus 3 radical 3 and 4 minus 3 radical 3. And so those will be my three answers. 3, and then 4 plus 3 radical 3, and then 4 minus 3 radical 3. And so that will be my three answers to that. So just remember, do synthetic division, and then do quadratic formula after that as well, and then you would get your final answer. All three of them. You're going to get three answers for this because it was a degree of 3. All right, another type of problem that we're going to review right quick is whenever we factor completely. For this one, I've got n cubed plus 6n squared minus n minus 6, and I want you to factor this completely. What I notice here is that I've got 4 terms. I've got 1, 2, 3, 4. And because I have 4 terms, I can do something called factor by grouping. And what grouping is when you take your 4 terms and you group them into 2 distinct groups. So I'm going to have my 2 groups right there. And then below that, what I'm going to do is I'm going to factor out my GCF from each group. So my first group, I notice it's got n cubed and 6n squared. So its GCF would be n squared. So I'm going to have n squared. And then that leaves behind n plus 6. Then in my second group, I notice I've got that negative right here, that negative right there, so I've got to take that out. But there's nothing between an n and a 6, so all I can do is take out a negative 1. So I take out a negative because that negative sign right there, and I take out 1 because that's what I have in common. And then what gets left behind, well, negative n divided by a negative 1 is a positive n, and then a negative 6 divided by a negative 1 is a positive 6. Remember, with this problem, you can always tell if you did it right, because these two things right here should be the same thing. They should match up. And they are. N plus 6 is in both of those parentheses, which means when I factor this, what's in parentheses, that's one of my factors. What's not in parentheses, so this n squared minus 1, that goes in another one of my parentheses. So I get that into factor to be n plus 6 and n squared minus 1. Now, once you've written that, though, I want you to put the letters DOTS below this one, because this is actually a difference of 2 squares. So this wouldn't be my final answer, because the directions say to factor this with the word completely. Well, this isn't factored completely, because I can factor a dots. The way you factor a dots is draw 2 sets of parentheses, then ask yourself, what's the square root of n squared? Well, that would be n. And then what's the square root of 1? Well, that would be 1. Just make sure that 1's positive and 1's negative. And so this would actually be my answer, factored it completely. Not to say that this is not a good answer, but this is not completely factored. This one below here with the star, that's the one that's factored completely, which would be the complete answer. So just remember, when you see a dots, you factor it like that. So an example, like let's say you had n squared minus 4 on the test, then you factor that into the square root of n is n, square root of 4 is 2, and 1's positive, 1's negative. So just be able to recognize a difference of 2 squares. because that's going to be something you can factor. All right, so that's one type of problem again. Another one is something that looks like this. All right. Now, for this one it says to find the inverse. So for this one it's got h of n is equal to the cube root of n plus 2 plus 1. H of n is equal to the cube root of n plus 2 plus 1. It wants you to find the inverse. Well, when we find the inverse, there's a couple of steps that you have to do. First of all, what you do is you rewrite this a little bit better. I'm not going to use h of n and n. To help me out, I'm going to use f of x and x, so that way I can do it better. So this, I'm just going to rewrite this, so I'm using f of x and x. So I'm going to rewrite with f of x and x instead of h of n and n. All right, the reason why I want to do that is because now I'm going to change the f of x to y. So this f of x I'm going to cross out, and I'm going to say that's equal to y. So y equals the cube root of x plus 2 plus 1. And then the next step is we're going to switch around the x and the y. So you see it's got y equals the cube root of x plus 2 plus 1. All I'm going to do is I'm going to switch those two around, because that's what it means to find the inverse. You switch the x and the y. So I'm going to have x equals the cube root of y plus 2 plus 1. And so all I did was just change the x and the y around. And now to get my inverse, all we're going to do is solve for y. So I want to solve this for y. So to solve this for y, I'm going to subtract 1 from both sides first. And so that will give me x minus 1 equals the cube root of y plus 2. The way that you get rid of a cube root, because we've got to get rid of this cube root, the way we get rid of a cube root is you cube both sides. And so what you'll have over here is x minus 1 cubed equals, and the cube root and the cube cross out, and that leaves me y plus 2. And then to finish solving this for y, I just subtract 2 from both sides, and that gives me x minus 1 cubed minus 2. And that is equal to my inverse right there. X minus 1 cubed minus 2. And that's my inverse. So remember, 4 steps. Write it with terms of f of x and x, and then f of x is equal to y, and then you switch the x and the y around, and then you solve for y. And that's how you find the inverse, those steps. So switch the h of n and n. So this h of n and n, switch that to f of x and x, and then scratch out the f of x and replace that with y, and then switch the x and the y around, and then just solve it for y. And that would be your inverse for that problem. All right, the next type of problem that you're going to see is something similar but a little bit different. So it's going to be doing complex numbers. I think that was the first problem that we did on the very first test. And so here's what that looks like. All right, so complex numbers is after this, and then we're going to go back and review quadratic formula. All right, so for this one, it says to find g of h of n. So this one, we learned it was something called function composition. So that was what we learned on test 4, I think it was. It says find g of h of n. Well, notice I tell you that g of n is equal to this, negative n squared plus 1, and I tell you that h of n is equal to 3n minus 3. And so I want to do function composition on this. So remember what I told you when we did this, you start on the inside and work your way out. So this is g of h of n. So I'm going to start with the inside. So I'm going to start with that h of n, and I'm going to plug that into the g function. So let me start right here. So you're going to start with the h of n. So you see I'm circling right there, and you're going to plug that into the g function. So you see right here an arrow to that, the g function where the n is. So wherever that n is, I'm going to replace it with this 3n minus 2 that I just circled. So here's what that would look like. You'd have a negative on the outside, 3n minus 3 squared. So you see I literally took that n and I just replaced it with 3n minus 3. So put that in, and I put plus 1. And so that's what it means by function composition. Take one function and plug it into the other. Now, we're going to have to fix this, so I'm going to FOIL this out first and then distribute. So what I mean by that is I need to FOIL this out to simplify it. So I'm going to FOIL this out right here. So what I mean by that is 3n minus 3 squared. That literally means 3n minus 3 times 3n minus 3. And so I'm going to FOIL this out, and I'm going to get 9n squared minus 9n minus 9n plus 9. And then I notice these two in the middle do not cross out, but that gives me negative 18n. A negative 9n and a negative 9n give me negative 18n. So that's what I get when I FOILed this out. So I've got negative, and then in parentheses, 9n squared minus 18n plus 9 plus 1. And so that's my FOILing part. The next part is I'm going to go ahead and distribute that negative 1 that's right here. So I'm going to distribute that negative 1, and I'm going to get negative 9n squared plus 18n minus 9, and then that's going to give me negative 9n squared plus 18n minus 9, and then don't forget the plus 1 that's right there, because the last step is to combine my like terms, and my like terms are right here, negative 9 plus 1. So that'll give me my answer of negative 9n squared plus 18n minus 8. And so just to reiterate the steps again, what you're going to do is you're going to start on the inside, so start with the h and the n, and then plug that into the outside, so plug that into G. So h of n, plug it into G, and then you've got to FOIL, distribute, and combine like terms. And then that would be your answer for that problem, just doing function composition. So FOIL, distribute, and then combine like terms. And then that would be it for that one. All right, for the next one, I think I saw it was complex numbers. So for test 1, complex numbers, I had this type of problem. I've got 7 over negative 5 minus 3i, and it wants you to simplify this. This is dividing complex numbers. So the main word you had to remember for this was the word conjugate. And so the conjugate of negative 5 minus, the conjugate of negative 5 minus 3i, its conjugate would be negative 5 plus 3i. So just remember that. That's the word conjugate right there. And so when I see this problem, what I'm going to do is I'm going to multiply by the conjugate, which will be negative 5 plus 3i, and so that will be negative 5 plus 3i. And so what I'm going to do is I'm just going to multiply this. So I'm going to start in the numerator, so I'm going to distribute 7 times the negative 5 is negative 35, and then 7 plus 3i is going to be plus 21i, over, and then FOIL in the denominator, so negative 5 times negative 5 is 25, and then negative 5 times 3i is negative 15i, and then negative 3i times the negative 5 is a positive 15i, and then negative 3i times 3i is negative 9i squared. And so what I'm going to do is I'm going to clean this up a little bit. And so two things right off the bat. I noticed that this I squared is always equal to negative 1. And then right here, the negative 15i plus 15i, that crosses out. So this leaves me negative 35 plus 21i over 25 plus 9. So 25 plus 9. And so that gives me negative 35 plus 21i over, and then 25 plus 9 is 34. And so then that will be my simplified answer for that. So when you're dividing, just remember, do the conjugate. The conjugate. The conjugate of this problem was negative 5 minus 3i. The conjugate of negative 5 minus 3i is negative 5 plus 3i. And so then you just multiply, distribute the top, and FOIL out the bottom, and that would be your answer for that. Now, another complex number problem is whenever we wanted to multiply two things together. And so then what we're going to have is, we're going to have negative 6 minus 3i, and then 6 minus 4i. And so what we're going to do is, we're going to just FOIL this out. And so negative 6 times 6 is going to give me negative 36. Negative 6 times a negative 4i is going to give me a positive 24i. Negative 3i times 6 is going to give me a negative 18i. And then negative 3i times a negative 4i is a positive 12i squared. And so then the next two things I'm going to do is I know that this is I squared, so that's equal to negative 1. And then I can combine these two together. So I'm going to have negative 36. 24i minus 18i is going to give me 6i, and then 12, but this I squared is negative 1, so that's going to give me a negative 12. And then I notice that I can combine my like terms here, negative 36 and negative 12, that's going to give me negative 48 plus 6i. So to go back over it one more time, for this problem we're going to FOIL, so we're FOILing this, so negative 6 times 6 is negative 36, negative 6 times a negative 4i is a positive 24i, a negative 3i times 6 is going to give me a negative 18i, and then a negative 3i times the negative 4i is going to give me a positive 12i squared. And so that would be my answer for that problem. Alright, so for the last one, I have a solving by the quadratic formula. The biggest mistake with this one is making sure that you move this number to the other side. Because remember, with quadratic, it's got to be equal to 0. This isn't equal to 0, it's equal to 3. So I'm going to move this 3 over. So I'm going to get 2p squared plus 3p minus 3 is equal to 0. And so then what I'm going to have here is A, B, and C. And so I'm just going to plug it in the quadratic formula. I'll have negative 3 plus or minus the square root of 3 squared minus 4 times A times C all over 2 times A. Remember, you can't type the whole thing into your calculator. You can only type in the discriminant, which is that part right there. So I'm going to have negative 3 plus or minus the square root over 4. And then if I plug this into my calculator, 3 squared plus 24, that should give me 33. So this will give me negative 3 plus or minus radical 33 over